Earth and Venus were once considered perfect twin sisters of the solar system.
They share nearly identical size, mass, and were formed from the same cosmic dust cloud. Yet on the surface, one became a vibrant haven for life, while the other turned into a brutal hellscape. Temperatures hot enough to melt metal, and atmospheric pressure that would crush a nuclear submarine.
What caused these twin worlds to diverge down such radically opposite paths? Today, we conduct a comprehensive comparison of the surface conditions on Earth and Venus.
Human space probes sent to Venus survived for only a few fleeting minutes before being destroyed.
Earth grants us breathable air, oceans to swim in, and temperate weather. Venus traps you in a giant, inescapable planetary pressure cooker.
Where does this extreme divergence begin? Let us start with the first factor, atmosphere. The atmospheric envelope is the ultimate key determining the fate of any planet.
At Earth's sea level, average atmospheric pressure stands comfortably at 1 bar.
On Venus, surface pressure reaches a crushing 92 bar. That is 92 times greater than Earth. This is equivalent to the crushing depth of 900 meters beneath Earth's ocean surface.
Without extreme shielding, an unprotected human body would be instantly flattened in a fraction of a second.
Why is Venus's atmospheric pressure so terrifyingly high? The answer lies in its composition. Earth's atmosphere consists of 78% nitrogen and 21% oxygen, forming a light envelope.
Meanwhile, 96.5% of Venus's thick atmosphere is hypercompressed carbon dioxide.
Near the surface, CO2 is compressed into an exotic state known as a supercritical fluid.
To make matters worse, Venusian clouds are composed of pure, highly corrosive sulfuric acid. Acid rain falls from above, but evaporates 25 kilometers above the ground due to extreme surface heat.
Compared to the life-giving freshwater rains on Earth, this is a stark planetary contrast.
In 1982, the Soviet Venera 13 probe landed on Venus and survived for just 127 minutes.
That remains the longest survival record for any artificial probe on the Venusian surface.
Earth maintains stable pressure thanks to its natural carbon cycle and vast oceans.
Venus lacks oceans to absorb carbon, causing its atmosphere to grow denser continuously.
The total atmospheric mass of Venus is 93 times heavier than Earth's entire atmosphere.
That suffocating atmosphere acts as a toxic blanket, wrapping the entire planet.
And this blanket ignited a thermal inferno. Extreme temperature.
Earth's global average surface temperature sits at a comfortable 15 degrees Celsius.
On Venus, average surface temperatures soar to an astounding 465 degrees Celsius.
This heat is intense enough to melt solid lead into liquid puddles on the ground.
Frigid. Even though Venus receives only half as much solar radiation as Mercury,
it is far hotter due to a runaway greenhouse effect.
On Earth, our natural greenhouse effect warms the planet by about 33 degrees Celsius.
It maintains liquid water and enables biodiversity to flourish worldwide.
On Venus, as temperatures rose slightly, ancient oceans began to boil away. Water vapor, a potent greenhouse gas, trapped even more heat in the sky.
Extreme heat broke down carbonate rocks, releasing trapped carbon dioxide into the air.
A runaway positive feedback loop locked Venus into a permanent planetary furnace.
Remarkably, there is zero temperature difference between day and night on Venus.
Whether at the equator or the poles, temperatures remain fixed at 465 degrees Celsius year-round.
Earth experiences distinct day-night cooling and seasonal climate shifts.
Venus rotates extremely slowly. One single day on Venus lasts longer than its entire year.
However, super-rotating upper winds at 360 kilometers per hour distribute heat evenly everywhere.
The surface is bathed in a dim orange glow, where direct sunlight never penetrates. Earth enjoys crisp sunlight, driving photosynthesis and powering life.
At night, Venusian ground rocks glow with a dull, eerie red heat.
Under 92 bar of pressure, water would only boil at temperatures over 300 degrees Celsius.
Yet at 465 degrees Celsius, not a single drop of liquid water can exist. This total dryness leads to another planetary mystery: volcanic geology and plate tectonics.
Earth's surface is fragmented into shifting tectonic plates. Plate tectonics recycles Earth's crust and regulates atmospheric carbon levels.
Venus lacks active plate tectonics. Its outer lithosphere is a single rigid shell.
Scientists believe that without water to lubricate mantle movement, the crust remains locked tight.
Unable to release internal heat continuously, thermal energy builds beneath the crust for millions of years,
leading to catastrophic global resurfacing events where the entire planet erupts at once.
80% of Venus's surface is covered by vast, flat basaltic lava plains.
It boasts over 1,600 major volcanoes, more than any other planet in the solar system.
Unique formations, like pancake domes, were created by highly viscous silica lava flows.
On Earth, volcanoes are primarily concentrated along tectonic plate boundaries.
New radar data analysis suggests several volcanoes on Venus remain active today.
Earth bears visible impact scars from meteorites spanning billions of years.
In contrast, Venus has few small impact craters. Its dense atmosphere incinerates incoming meteoroids.
Only massive asteroids can penetrate the atmosphere to leave craters on the surface.
Venus's surface is geologically young, estimated at 300 to 600 million years old, while Earth's continental crust contains ancient rocks up to 4 billion years old.
Island regions, known as tesserae, are folded rock formations that hold clues to Venus's ancient past.
Earth's canyons were carved over millennia by water erosion and ice action.
Channels on Venus were gouged out by long rivers of flowing liquid lava.
Why did Venus lose all its water and turn into a bone-dry desert?
The secret lies in an invisible planetary shield, the magnetic field.
Earth possesses a rapidly spinning liquid iron core, creating a strong geodynamo. This magnetosphere shields our atmosphere from relentless solar wind erosion.
Venus rotates too slowly to generate an internal planetary magnetic field. Without a protective magnetic field, high-energy solar radiation strikes its upper atmosphere directly. Ultraviolet light splits water molecules into hydrogen and oxygen, stripping them into space.
Light hydrogen gas escaped rapidly, stripping Venus of any chance to replenish its oceans. Earth retained 1.3 billion cubic kilometers of water under magnetospheric protection.
Spectroscopic data reveals Venus has a deuterium to hydrogen ratio 150 times higher than Earth.
This proves Venus once held abundant liquid oceans in its early history. For its first 2 billion years, Venus may have been a habitable blue world.
Could primitive microbial life have evolved in Venus's ancient oceans? In 2020, the detection of trace phosphine gas in Venus's clouds ignited global scientific debate.
At an altitude of 50 kilometers, conditions are surprisingly mild, 1 bar of pressure and 30 degrees Celsius.
This cloud layer represents the last potential sanctuary for aerial microbial life.
Upcoming missions like NASA's Da Vinci and Veritas aim to solve these mysteries. Europe's Envision probe will study the link between Venus's interior and atmospheric evolution.
One world preserved life, the other degenerated into an infernal desert. Venus serves as a tragic mirror into the distant future of Earth.
As the sun brightens over billions of years, Earth could face a similar runaway fate.
Studying Venus reminds us how precious and fragile Earth's equilibrium truly is.
Earth remains our only home in the vast cosmic dark.
From crushing pressure to scorching heat and toxic skies.
Venus proves how delicate planetary habitability really is.
Do you think humanity could ever terraform Venus? Share your thoughts below.
Thank you for watching. Don't forget to subscribe to continue exploring the mysteries of the universe.